Good day, Ms. Mel. This is RHEENA'S, and for today's video, I will be going to make a reflection video by answering the following questions. So without further ado, let's start. Number 1 question is, what did you feel about studying lesson 1? Is the lesson boring and ineffective? Is the lesson interesting and effective? Lesson 1 is all about the overview of biochemistry and the occurrence of carbohydrates. For me, this lesson is very interesting and very exciting to study. While I was reading the lesson, I understand what is biochemistry. It is a discipline of both chemistry and biology and is the study of chemical processes within and relating to living organisms. It is used to learn about the biological processes which take place in cells and organisms. It is used to study the properties of biological molecules of a variety of purposes. And also, this lesson widens my knowledge about the importance of carbohydrates. Carbohydrates, also called carbs, are a type of macronutrient found in a certain foods and drinks. It is the main source of energy for our body. Studying carbohydrates in this lesson is important to be able to know how many carbohydrates do we need in our body and to learn the effects of carbohydrates on our health. I can say that I am proud that this lesson is aligned in my course because it is very useful to me. I have learned a lot of things in this lesson and hopefully I will be able to survive in this lesson. Number 2 question is, what are the topics encountered in lesson 1 that you find difficult to understand? The topics that I found in lesson 1 that is difficult to understand is chirality and stereoisomerism. I found this topic difficult. It is because you need to understand first the concept of spatial arrangement to understand stereoisomerism and chirality. Stereoisomers are isomers that differ in the spatial arrangement of atoms rather than order of atomic connectivity. One of their most interesting type of isomer is the mirror image stereoisomers, a non-superimposable set of two molecules that are mirror images of one another. The existence of these molecules is determined by the concept known as chirality. A molecule sharing the same atomic makeup as another but differing in structural arrangements. This article will be devoted to a specific isomer called stereoisomers and its property of chirality. The concept of stereoisomerism and chirality command great deal of importance in modern organic chemistry, as these ideas helps to understand the physical and theoretical reasons behind the formation and structures of numerous organic molecules, the main reason behind the energy embedded in these essential chemicals. Number 3 question is, what are the topics encountered in lesson 1 that you find easy to understand? The topics that I found in lesson 1 that are easy to understand are the overview of biochemistry and the occurrence and functions of carbohydrates. These topics are easy to understand, especially if you read the provided definition in the lesson. These topics also widen my knowledge about biochemistry and the importance of carbohydrates in biochemistry. And the last question, number 4, is, why do I need to learn about left and right-handed chirality molecules? Cells are composed of chiral molecules. An object or a system is chiral if it cannot be superimposed onto its mirror image. Our left and right hands represent a familiar and convenient example of chirality. The left hand is a mirror image of the right one, and they cannot superimpose no matter how the two hands are oriented. Chirality is a particular important concept in biology because cells are mostly composed of chiral molecules. Small chiral molecules such as amino acids and sugars are the building blocks of larger molecules, such as proteins, and nucleic acids, which are also chiral. A chiral molecule and its mirror image are called enantiomers. One is dextrorotatory, or D, and the other is levorotatory, or L. Ordinary chemical reactions produce L and D molecules in equal amounts, referred to as a racemic mixture. However, related biological molecules have the same chirality. Most amino acids are L and most sugars are D. This situation is called homochirality, and the homochirality of biological molecules is a characteristic of all living things. The amino acids are very rare in cells, although some specific activities of the amino acids have been identified. So that would be all my video reflection. Thank you, Ms. Mel, for watching and have a good day.